Here we go.
Okay. So today's my birthday, so we're gonna do a problem about birthday cake. So how much? Yeah, I personalized it. So if I wanted to figure out how much cake there is, what kinds of things do we need to know?
We are going to assume the cake is 2D,
Yeah.
not 3D.
It's like a cookie cake.
It is like
Yeah,
or pizza.
that's a good.
We figured we might do a pizza.
I just
But,
want to cake.
but it's not a birthday, so it's
What kinds of things
what
do
kind
we
of
need?
things do we need to know about finding the
Isn't that area?
A radius.
radius? We need the radius.
What'd you say, Danielle?
Isn't that the area?
Yeah. Anything else? What other?
Radius and circumference?
Mm-hmm. Okay. So, say that this cake had a radius or a diameter of 10.
Yes. Cake has a diameter of 10. What would the radius be? Brittany?
5.
5. Radius is 5.
Okay.
Anybody remember how to find the area? Pi r squared.
What is pi?
Not cake.
No, that's so good. That's kind of what I was hoping someone would say. What is pi? Like
It's a
math.
number?
It's a number.
3.14? 159.
Yeah.
Goes on forever.
Right. Dot. Okay.
For our sake, we're going to use 3.1415.
Mhm.
Should we calculate the area?
Sure.
Sure. How everybody takes out notes and calculates the area. Awesome.
So we should use 3.1415?
Yeah.
You could use 25 pi too, or you could use pi as well. Whichever you want to do.
Awesome. So we found. Tegan, do you want to come show how you found
Sure.
how much pie, how much cake there was?
Hi.
Oh wow. Ignore that.
Is that another Greek symbol that we haven't learned?
And
Did
I
anyone-
didn't do it out.
Did anyone
I
come up
did.
with the decimal point or the decimal form?
78.5375.
Okay. That's a 5. Awesome. So, what if we cut this cake?
Hold on, we just gave you this.
What?
We just gave you that. What if we cut the cake?
Oh,
You and 11 of your friends cut the cake into 12 equal slices. The first slice is given to you, I should say. What is the slice of cake called in relation to the rest of it? I put not a scale because I didn't do very well at splitting it in equal 12ths. So,
Oh, these should all be equal size
yes,
pieces.
do we need clarification on what the question is asking?
Raise your
what
right
it's
hand.
called?
Are we trying to remember this from the previous
No,
class?
this is introduced.
Yeah. Carmen?
It's called a piece.
A piece.
I
What
was
would
gonna
that
say
be?
piece.
A piece.
So you got a
Any
piece of
other-
cake. Any other?
Any other ideas? Have you ever heard it called anything else?
Sliver.
Sliver.
If you have a really small
Yeah.
a slice.
I think it's called sliver.
Yeah.
Right?
Yeah.
Slice of cake, yeah.
Yeah, a slice.
Or
Okay. So these are all words to describe this one piece, right? Here. This guy.
So what is your piece on your birthday, Nellie? Miss
I'm gonna
Allison.
tell you that it's called a sector.
We should have this written down in our notes.
This guy.
Should we just draw a circle and draw an arrow that says?
Yeah, or
You
you
can
could,
shade it
you could
in,
take out a little piece.
whatever way
you know,
visually
sector.
Oh my
help
God,
you the
mine
best.
Terrible.
Awesome. So, if this whole piece is called a sector, what are the parts of this piece? What is in?
I don't know what you're looking for.
I'm just asking for any ideas. Can be anything.
About what?
About this sector, so that like a circle has parts like the area, the circumference,
Oh.
the diameter, the radius.
What is-
What kind of parts does this
It has
is
an
this made
area.
of? Yep,
It's the
it has an
It
area,
has a radius.
has a radius.
Has
There's a chunk of this
real
around.
portions.
Mm-hmm.
Ooh, it has a
Wait,
chunk.
Oh, okay.
It has a
It
chunk.
doesn't have a radius, right?
The Mhm. radius
is part of it.
Okay,
So the
what
radius of the circle is there.
where
but it
is,
doesn't
can you
have
show
a
me
radius.
where the radius of the circle is on this?
Someone drop a red skittle. I'll color it.
No.
So I think this is.
Oh.
Oh, you
I
can take-
think-
You can take it out if you want.
This is a radius, and
Yeah.
I think this is also a radius.
Oh, okay. So those are the sides left of it, or the radius.
Yeah.
Okay. What about this piece? I think Tegan looks like a carrot. Tegan used a word. You called it
It's a part of the
a
circumference.
part of the circumference. Okay. So this part of the circumference is called an arc.
So we should have sector and arc written down in our notes.
Great.
I believe. Are we ready to move on?
Does everyone have
Is
all
everybody
the?
ready- Is everybody ready to move on?
Yeah.
Is there
Okay.
any questions, confusion about what we have just written down in our notes? Alright. So, you wanna know how much of one sector or one piece of cake is? What is the area of the slice of cake that you are given on your birthday? So between one of 12 of your friends, or one of your 11 of your friends and you. So, let's try to figure out that.
Does everyone understand the question?
Yeah.
Does anyone have any question?
Tegan, question?
So we're trying to find the area of that piece?
Yes.
Mm-hmm.
Oh, okay. Okay.
Question. So there, it looks like that's a semicircle.
Yeah, this is just a really poorly drawn sector. I'm actually gonna.
So if
Take
we.
that, copy that, duplicate that.
Can I drag it to it?
Here's this.
Yeah, so that's supposed to represent R, I think is what.
So do we know
Danielle
how to
just
find
asked.
the rest?
Copy. We want you to come up with a way to find.
Okay.
Cause you found the area of the whole circle, right?
Oh.
We want you to
Yeah,
find
we
the,
did.
we want you to find the area of a piece.
Pretend like this is a piece of the cake. cake.
Okay.
Just completely taken from.
So that like semicircle isn't a semicircle.
Yeah, it's just, this is just one piece, one slice of
Okay.
cake. It's fine, it's not working, it doesn't seem. Can you do like control? Okay, cool. So this is the piece now. Let's see. Okay. So where does that come from?
Well, you said that the area.
No, is it you and 11 of your friends or you and 12 of your
You
friends?
and 11 of your
And then we
friends.
split it into 12 equal pieces.
Yep.
So you can do that.
Okay.
Which is also the same as just going to 12 that way.
Oh, okay, I see. So,
Oh, you find the area from the.
yeah.
Yeah, no, I'm saying that's all we have to do.
Yeah.
Find the area of it.
Yeah. Yeah.
Okay. Okay, so I want you to go over and work with Danielle, if that's all right, and if
I don't
you
know
go.
what I'm doing.
That's fine. Let's see. So we have 12,
Maybe we can
12 equals
maybe
pieces.
Carmen can explain it to you, what she did. Carmen, can you
So-
explain to Brittany what you?
What is this, what is the shape of this
Seems
piece?
to be divided into 12 pieces
No, it's
by
not.
total
Yeah.
area.
I think that's your, was your first misconception.
And I wrote 2.5.
There you go.
It's the same thing. Right? Oh no, that is not the same thing.
So
That's
it's
horrible. Oh my
I
god.
think all we're doing right now is
Oh my god.
Yes.
Horrible.
And it was like, what's the difference between, it was like 7 and -4, and I'm like, or no, it was 4 to -4, and I was like,
I don't know, cause I know you can like multiply the outside arc.
It's
Or
something
wait,
along
we're
those
looking
lines
for
where
the
one
arc.
is positive and one is negative, and I was like, oh, well, so
I
it's-
I
it
know
was
arc.
No.
No, but I
Not
was-
yet.
and then I felt really stupid after.
Yeah.
And I was like
That
totally,
would be the
oh,
next
it's
question.
Right, right.
Now we're trying to find the area.
It's definitely gonna happen in front of the class.
Once
Okay.
we've done that, we can try
So-
to
That
find the
happens to
angle.
me all the time.
so we have this number 25, 5, and 12. So,
6.5.
so what is that, can we find that in a decimal maybe, compare it to.
Right, it's in inches, but no.
Compare it
It's
to
10
inches.
the whole.
Yeah. So it's 2 and a 12.
Yeah,
Right.
very good.
Yeah.
How are we gonna
So
solve
what's
the
a
next
12?
problem?
6.
What angle
8 point,
is the piece of cake cutting?
what is it, 12?
I just did 360 divided by 12.
Oh, yeah, those that's for later basically.
So it'd be 2.0.
That's for like the arc.
And then I see the expression is what is the arc.
Because our length is
Alright.
equal to angle time.
I thought you did something with.
So we get.
So yeah, we haven't gotten, so that's like after
Right, it is found.
the area, okay, so then try to have them do it with like another number and try to find the jump.
Find the area.
Yeah. So, okay, so what if there were 13 pieces?
It's like 120.
1/12 of the circle.
So if we figure out the circumference.
Okay. So can you come up with a general formula maybe to come up with,
For just this size?
yeah,
Or any size?
we'll do it for this size and then maybe you can get to the any size later.
Group X pieces.
I mean, 10 pi.
25 pi over x.
Yeah.
And then if we just
31.41
It's
pi.
basically the area over minus.
so.
We did 2.618.
guys come up with a formula for area and circumference that you use to solve
Well,
this?
yeah, just stick with area for now.
For area, we'll start with area. Just like a general formula
For area of
Just
a
like-
cake or
like-
of a sector?
of a sector.
Area of a sector.
The area of a sector. So if I gave you the same cake and told you to cut it into 6 pieces,
You guys
is
come
there
up
a,
with
is there a general formula you could have?
Yeah, we could.
Mhm.
Okay.
Cool. It's like the area of a pumpkin
So,
divided by
what if,
pieces.
Cool, why do you
What
think
if
that? Will that
we
work?
didn't use a bunch of equal slices?
If it was a six, it
What if I just said
As long as the pieces are
this size piece
As
of
long as it's like equal, awesome. Very good.
maybe that's not very much.
And you found
So,
the arc?
they would all be different sides.
So
Yeah,
there's a
they're-
formula
they're
for
It's like if we
size
did
because
over
of
12
the arc.
slices.
So we would
Yes,
still
try
say
to
the
find a
area
formula
is
for the link to the
pi
arc
r
as well.
squared
Mm-hmm.
divided by.
Well, if you knew what fraction of the whole it was,
Yeah.
because this is
Oh,
the
So we
okay.
would have to know this angle.
Mhm.
So if we call that theta, then
Oh.
so
Yeah.
theta, we call it A for equal.
Okay.
Is, or
So-
360 is gonna be a fraction of. So we can set that equal, because shouldn't
Mhm.
the ratio of this part to the whole be the same as the area, as the ratio?
Yeah.
So if I had you guys explain these guys, would you be able to?
Sure.
Okay, cool.
Circumference times. Yeah, why do you think it's circumference times the fraction of the section?
Well.
What did you do?
We took the entire circumference and then we said, well, this is 1/12 of the circumference.
Okay, so you're multiplying by 1/12.
Yes.
So Carmen, what did you do?
I did divide by the number of pieces, which I think
So this-
if,
Oh, I still did
if we're only talking about one piece, we cannot use pretty example, which is maybe, but you're gonna work in more cases.
Wait, say that again? If you're only using one piece, you can use.
Yeah, cause if it was like, 7/12 of the circle, my formula doesn't work.
Oh, I
because
got
it's
you.
12 pieces, right?
Mhm.
So your formula won't work.
Cool. So how would you change your formula, Carmen? Or how could you use your formula if there was 7 pieces? What would you do?
So then it would be like
Mhm.
total number, but I've also multiplied by what number of pieces you want.
Yes. That's good. You already figured out an
So
angle?
if I, no worries. So, what kind of units would be attached to
the amount of
this,
pieces there were.
to this number?
Is there a relationship between the angle and the arc?
Whatever the area is. Whatever,
Okay, so the area, yeah,
like whatever you
Think about
use,
that for
the
a second,
area
I'll
is.
be back.
yeah.
Because it's a portion of the
Mhm.
area.
So how would you, if I said this, the diameter, was it 10 inches?
Mhm.
So what kind of
whole.
units would this be?
Inches squared?
Yeah.
Yes, so.
Would that be the
usually
same if I said it centimeters?
Over
Yeah, it'd be centimeters.
60
What about,
Mm-hmm.
times, inches per yard.
where's my units?
Meters.
Feet. Yeah. 10 feet, that's a big case. That's a good purpose. Okay.
So that makes this one
But we're not
12.
supposed to be
Mhm.
to do like circumference till after they explain the area.
Either way.
Yeah, exactly. Cause I wanted them to explain this
Okay.
and then do that, but I guess well, they're already just like ahead, kind of, we'll have them explain. Do they get a general formula for area?
Because we can be in the
Okay.
Do you
Okay.
want to bring back?
Kind of, cause I just wanna work on area
Okay.
first and then. So, alright, so now we seem to have gotten to a point. So, yeah, can one of you guys bring your paper up there?
You gotta figure out the relationship.
Good luck.
I don't care.
I'll bring mine.
Okay.
Let's see. We're gonna go over area right now, I believe.
Mm-hmm.
Whoa, so what am I explaining?
Explain how you found the area of the sector.
Okay, so we knew that our total area was 25 pi, and since we had 12 parts, we did 25 pi over 12, and we figured out that 25 over 12 is 2.08333 repeated times pi is about 6.54.
Cool. And what was the area of the whole circle?
25 pi.
What do we know that in the decimal form? I think it was like
78.5375.
okay.
Just the same answer you two came up with? Pretty easy.
Yes.
So everybody
Given
understands.
it just squared.
So you understand how we got here? Yes. Remember to put your units in TEM.
Let's see.
Yes.
Sorry.
So, alright. Cool. Why are the units squared? Why isn't it just inches?
Because it's area, so it's space inside of something.
Okay. Nice. Cool. Can you explain your general formula for me?
Yeah, so if we have x pieces, we take the area and divide it by x, just like we did with the 12.
Okay, so that's for how many pieces? That's right. Great. Could you guys explain his formula? Did you have the same formula?
Yeah, the same. So we took the total area and we divided by the number of equal pieces.
Okay. Did you guys think about the formula if all the pieces weren't all alike?
Maybe not all equal.
Mm-hmm. Did you guys think about that at all? Danielle, I think you did some work on that, right?
They weren't equal?
Yeah.
Yeah.
You wanna come show that?
Yeah. So it's kind of all over the place, I
Mhm.
apologize. So I said we know that we would still start with the same area.
Mm-hmm.
So pi r squared is the area of the whole cake. And then here we divided by the number of pieces, but I thought each piece,
What's the word for piece?
sector?
Yep.
So, I was thinking that, what was it? I was thinking that this might vary depending on not how many pieces, but like the size of the piece compared
Mhm.
to the whole. So I said if,
What was that? The size of the piece?
compared to the whole cake.
Oh, okay. So kind of like
Yeah. So, yeah. Exactly. So I said if this piece was theta degrees, cut at theta degrees, then I said I think that the relationship between theta and 360 would be the same as the area would be equal to the area of this sector over the area of the whole cake.
Oh, okay.
So then I said that theta over 360 must equal the area of my sector over the total area of the cake.
Okay. So
Brittany, can you explain what Danielle just said?
No, you lost me right at the very end.
Can anybody else explain what Danielle said?
up to that, can you explain up to that very end?
Well, she noticed the relationship between the angle of the sector compared to the entire 360s, and she noticed there was a relationship between those two terms and the arc in relation to the entire circumference.
Okay. So what do you think you should do next?
So Brittany, you found the area of, or you found the angle of your sector, didn't you?
Yes.
So, if you plug that in right here, the angle, what did you have?
I got 30 over 360, so this would be the same as 1.
Would that be the same formula that you used to find the area?
Yes. No. Wait, what?
You found the area of a sector, how? Can you come show that you found the area of a sector?
Well, I did the total area over the number of pieces.
The total area over the number of pieces. Okay. Now, total area is what Danielle said, right?
Yeah.
That's the total area. Number of pieces, which you, in our case was 12. She had the degrees. Is 30 over 360 the same as 1/12?
Yes.
Can you now explain what Danielle did?
No, I don't understand. When you said X is the area of the sector, but isn't that what we're looking for?
Yeah, so you would solve
Oh,
for
so you
X.
cross multiply. I'm so
Yeah.
sorry. Okay.
Yes.
Gotcha.
I just said that this
Okay.
relation, that I think this relationship is true.
Can we take this and work with it a little bit?
Does everybody
You know.
does everybody understand what's Danielle did?
So you had theta over 360. What is 360?
Degrees in a circle.
Oh, okay. Equals x over,
Pi r squared.
and that's the formula for area you said?
Yeah.
Cool. So then, what word did you just use? I think you just said it, right? To solve for x? Oh, nice. How do you do that? Can you show me?
Sorry. Everybody follow up to this point. Carmen, do you understand what's
Yeah, I do.
at this point? Okay.
Can you? Okay. Yeah.
Yeah. This thing is so loud.
Mm-hmm.
Do you want me to do it?
Mm-hmm.
Do you want me to plug in theta?
Not yet. Just want to see what x equals. Cool. Would you believe that that works for all thetas and all r's?
Sure.
You wanna plug it in, plug your value in, see if it works.
What is the area? 5.
Well, you can. What was the radius? What was
Five.
it? Mm-hmm.
Oh, I thought you asked what the R was.
What's the area?
25.
Oh, right, 70 something.
Okay.
Does anyone have a calculator that they wanna help her solve that with? Was that the same that you found dividing the slice?
Yeah.
Cool. That's pretty awesome. So,
Are there any
Okay.
questions on how we got here? Karen, can you reiterate what you just did?
Yeah.
You mean Danielle's method?
Yes, Danielle's method.
Right. So Danielle was thinking that the fraction of that the area of the sector out of the whole area would have this same ratio as the area of the angle out of the whole number of degrees of the circle.
Mhm.
And so then she set up a proportion in order to solve for that.
Yeah.
Very good.
Great.
Okay.
So I want everyone to copy this formula to their notes, because this is going to be how to find the area of a sector. If x equals the area of a sector.
Do you want to see your
Oh, I'm sorry, I'm deep in thought. Probably not. Yeah, that's a good.